Okay, next up, we have a classic, often just called CS.app. It's Computer Systems, A Programmer's Perspective by Randall Bryant and David O'Halloran.
Ah, foundational text for sure.
This book really demystifies what happens under the hood when your program runs. It bridges that gap between high-level code and the actual underlying hardware. It's all about writing better software by deeply understanding the system's architecture.
Yeah, and when we think about the bigger picture, AI and ML models, they are incredibly computationally intensive programs,
Hugely intense.
and they're ultimately constrained by the hardware they run on. CSAPP provides you with the mental models to diagnose performance bottlenecks in those AI workloads.
Okay, like what specifically?
Well, for example, understanding the memory hierarchy, the different levels of memory from fast CPU caches down to slower main memory and data locality.
How close data is stored together.
Exactly. That understanding can lead to orders of magnitude performance improvements when you're training large models just by structuring data to maximize cache hits.
A cache hit, meaning the CPU finds the data it needs right there in its fast local memory.
Precisely. Avoids going to slower memory. Or, another thing, knowing about floating point arithmetic reveals how tiny, subtle rounding errors can sometimes cause model instability. That's critical in numerically heavy AI tasks.
Right. But the prevailing myth I often hear is, oh, my framework or my cloud provider, they abstract all the low-level stuff away, so I don't need to know it.
Yeah, that's a common one.
But abstractions aren't magic, are they? When an AI model trains inexplicably slowly, an AI code assistant isn't going to tell you, hey, your data loading pattern is causing excessive cache misses.
Exactly. It just doesn't have that physical context. Diagnosing and fixing that requires a human who understands that fundamental hardware-software interface. So to apply this daily, imagine you're optimizing an ML data pipeline. You use an AI maybe to generate an initial Python script.
Okay, standard starting point.
But if it runs slowly, you use profilers, sure. But then you, with that CSAPP knowledge, you ask deeper questions. Is it compute bound, limited by the CPU speed? Or is it memory bound, limited by data access speed?
Hmm.
How is the data actually structured in memory? This leads to informed refactoring, like maybe using a column-oriented format like Apache Arrow for contiguous data storage. An AI lacking that physical hardware model wouldn't typically suggest that on its own.
So in an industry where AI model training and inference costs are a huge concern,
A primary concern, yeah.
the ability to optimize performance is a genuine superpower. It transforms you from just an AI model developer into an AI systems performance engineer, making code run faster, cheaper.
It's a massive differentiator, especially as AI keeps driving more specialized hardware development. That expertise is gold.